So, mastering MSO scenarios, a step-by-step guide to creating your own. It's going to be a series of webinars where I go through some of the basics of MSO, learning the process of generating optimized mineable shapes from the block model. Okay, a bit about myself. My name is Mofazzal Ahmed. I am the mining consultant for Datamine. My focus is in underground mining. And today, also I've been with Datamine for almost 3 years. Before that, I've been in operations in different mines around Australia. I've worked in like copper, gold, polymetallics. I've worked in a few different commodities as well. For those of you that are not familiar with our company, this image shows part of the current software solutions that Datamine owns and supports globally. We have something for every part of the mining cycle, from exploration, production, reconciliation, engineering, environmental, and lab logistics. Today, we are going using Studio Underground, which is part of our planning solution. And this is a quick overview of the other portfolios and their product offerings. Now, without further ado, let's go into the demonstration. What is MSO? Minable Stope Optimizer. MSO is a true optimization tool, maximizing the value of recovered ore within engineering and economical constraints. It reliably estimates how many tons can be mined at what grade based on practical mining considerations. The right-hand side diagrams illustrate that. The key input, as you can see, is the block model, and then you have your constraints to get the optimized stope shapes. So how does it work? MSO searches for optimal mineable shape, taking into account ore body, geometry, economical and geotechnical parameters, and operational constraints. Input, you must have a block model. Optionally, you can have control surfaces and development streams depending on the scenario. Options and constraints, you can have engineering and geotechnical parameters. Additional options, you can have if you want to exclude or include certain materials, or you want to do a sensitivity analysis on a specific constraint. Finally, you have the output, which is your stope wireframes, sectional design strings along the slices, and the reserve reports for reporting purposes. It basically creates a tube based on the dimensions provided within the selected wireframe. And within each tube, it creates slices with the provided strike and dip, and then it combines those slices to find an economic seed shape. From the seed shape, it anneals the shape, molds the shape based on the engineering and geotechnical constraint to find the optimized shape. So that's basically how the MSO works in a simple nutshell. Now let's look into some of the scenario and how to set them up. So for today, I'm taking a very simple ore body, 2 lodes, a narrow vein, and almost vertical strike, almost vertical dipping ore body. To access MSO, you need to go into, for Studio Underground, under report, you go model reserve, mineable shapes. This is different for other in studio suites. So RM would have still be under report, but it will be it's not included as a package, so you need to have it as an add-on. You need to buy that. So when you're in MSO, there you have a structured workflow which will enable or assist you all through the process. Alright, to start off with, I'm going to create a scenario. So I'll click add a new scenario, and I'll put the scenario name NV Nervane Basic. And then under active scenario, I'm gonna have to select the scenario. The bread and butter input block model, I'm going to select the block model that I want. Optimization field is going to be my grade, and then the density, default density, is going to be the density, average density of the ore body or the load. Dip and strikes, I'm not keep them as default because they are dipping almost vertically. If you have a complex dip and strike, you can use the control surface for your block or your scenario. I'm not going to go through these. There are multiple options here. I'm just going to highlight some of the features that they represent. Data fields, if you want to in your report include a certain data field in the report, you can do so, and you can use a method. Output stopes is where you can select the name and the color of the stope. So for this one, we'll leave it as green, and then there's strings that are outputting. Report, you can change the report. You can also use custom output fields. For example, if you want to use ounces, if you want to create an ounce field, you can do so using the custom output field. You just need to work out the expression for it. And all these other options we're going to leave empty. I'm just going to focus on a basic scenario with the grade. Now let's look into the economics. So economics obviously is the economical aspect. So here what is the objective is to maximize our stope grade, which is above the cutoff. Method will be cutoff grade, and I'm going to select the discrete cutoff of 2 grams per ton. You can have multiple additional options as well as head grade target, which is more selective mining, so it's optimizing it will come up with less shapes. Orientation, so my block model is loaded. So orientation or framework extent is the radius or the area where MSO is going to work within. So you have to make sure that your block model is within that extent. Now, if you want to test on a smaller framework or smaller region, you can do so by manual definition. One thing good about MSO is it automatically picks up that it's a rotated model, and then it makes those changes automatically. So with, say for example, if I had to select half of this block model, I can change that distance, and that will select half of my block model. But for now, we're just going to leave as same as my block model. Next, I'm going to define the stoping method under the shape. So my stoping method, these are very easy and self-explanatory. So I'm going to select slice method. It's more suitable for narrow ore bodies. Next, I'm going to select vertical. These are vertical ore body, so I'm going to select that. And stopes along framework. So I'm going to select x-axis because that's where my strike is going to lead. So if I hit finish, it will create this framework for me, where U being the strike, V being the height of my levels, and W is the width of the stope. I'll just change this just to give you a different perspective. So if I do the same thing and then I go along the y-axis, now my strike becomes my y-axis, V stays the same, and W is the width becomes along here. So as you can see, this framework selection is very important. I'm going to put it back to x-axis. So the U stands for my strike. So I'm going to have a 15-meter strike. You can have variable ones as well. Level, I'm going to have 20-meter level spacing. And then I'm going to save. These are additional features that I'm not going to cover in this exercise. Next is control my stope width. So the width of my stope. So I'm going to go 2 meters. You can have apparent width and true width, and then true width on sections. I'm going to select apparent width. Minimum of 2 meters and maximum of 5 meters because it's a very narrowing stope. Minimum pillar between parallel stopes, so parallel loads, I'm going to go 10 meters, which is the stock standard. I'm leaving everything else as the default. Here you have the dilution, you can control the dip angles and the strike angle, as well as thickness ratio. I'm not going to go into refinement or materials. I'm just touching them. Materials, the way you include or exclude materials. Options is the post-processing options. Sensitivity, if you want to run the sensitivity analysis, you can select one of them. Basically adds more scenarios. Now I'm going to go to run. One thing you've got to be conscious is threads per run. This is based on the processor of your computer. If you have more core, it'll be much faster. So the more core you select, the faster it'll be. Alright, now let's run this scenario. Alright, it's already done for me, less than a minute, which is good. Bear in mind, it's not the same for complex block models or bigger block models. This is a very simple one. Let's have a look at this block model, this output. Okay, let me just get rid of the area of interest. Okay, so that is how it looks like. If I look at the property of 1, just having a look at one of the properties, so you can see you've got your volume, tons, cutoff grades, and then your height and length, which is your strike, and your average width. Okay, now we'll create more scenarios. Next, I'm going to create a new scenario. So I'm just going to copy my basic. So I'm going to hit copy, and this will appear. And this time I'm going to add dilution. Okay. Under scenario, active scenario, I'm going to select that NV dilution. Everything else stays the same. I'm gonna have everything else staying the same. all I'm updating is under controls. I'm going to have stope dilution. So I'm going to have stope dilution from a footwall and hanging wall of 1.5 meters along each side. Okay, and I'm going to save that, and I'm going to run. Let's have a look how that changes. Okay, almost done. Alright, let's have a look. So I'm going to add both of them. I'm just going to change the color of my diluted block models. Okay, and I'm going to look at them horizontally. Just so we can have a better view. So as you can see, now I've got a dilution skin of 1.5 meters along both sides. Okay, so that is the difference to add dilution. Next, I'm going to have another scenario. So I'm going to copy my basic, and this time I'm going to remove one of the loads. So it's going to be material exclusion. So I'm going to select MB materials, my new scenario, and then I'm going to go under materials, exclude material. I'm going to select ore body, so each of these load is defined by ore body 1 and 2. I'm just going to quickly show you that. So that's ore body 1 and this is ore body 2. So I'm going to define what I need to what I want to exclude. So I want to exclude ore body 1. So I'm going to select that column attribute. Maximum allowable will be 0. I don't want to include anything, and save. Now I'm going to run that. One thing is you can run all the scenarios in one go, and just for this exercise I'm running them separately to show you the difference. So you can create all these scenarios and then select all of them and hit run. You can also, if you have a powerful computer, you can also do concurrent runs. Basically they're going to run parallelly. Alright, let's have a look at that. So as you can see, I'll just change the material color. I'm just going to remove this so that's my new run, which is excluding materials from the other load, and that's the basic one which had 2 loads. Okay, finally I'm going to do a post-processing run. post-processing option, so I'm going to select smoothing. Okay, I'm going to select smoothing, and all I'm going to do is under options I'm going to go post-processing options, which is stope smoothing, fast and in, so fast combination, UV, which is along my strike and height, maximum of 2 meters. Save that and let's run. Alright, so almost done. Okay, let's have a look. I'm just going to change the color. Alright, best to see in an intersection along. As you can see, the purple is nice and smooth for me. It's almost like a drive that's following a drive, so it removes or tries to remove all the offset from the initial draw. Okay, alright, thank you for watching today and hope you have learned something new. If you have, or if you want to see something specific in MSO, please share with me. We also do run training courses if you ever want to have a more formal training. Till then, now we're going to go into the Q&A section to answer any questions that you would have. Thank you.